Unit 6, Polygons in Motion. Preview video 6.3, Part 1. Rectangles, rhombis, and squares. Oh my! Sit tall. Take a deep breath in through your nose. Ready? Inhale. Hold your breath. And birthday candle. So here we are, rectangles, rhombis, and squares. Oh my. Get a date, time, and location. Parental sign-offs, affirming you did this on your own. Now we already mentioned that rectangles, rhombis, and squares are descendants, if you will, or all related to a parallelogram. They're part of the parallelogram family. So that's why we're taking a moment and we are reviewing what are the qualities of a parallelogram, and they are OCD. First, definition of a parallelogram: opposite sides are parallel, hence the name parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. That means angles that are next to each other are going to add up to 180. And the last is the fact that the diagonals bisect each other. They go through each other's midpoint. These are the OCD qualities of a parallelogram. That's important to remember because a rectangle, a rhombus, and a square all qualify as a parallelogram. First off, I want you to imagine if you were to take a parallelogram and make all four angles of the parallelogram a right angle, what you would get would be a rectangle. So by definition, a rectangle is a parallelogram with four right angles. Therefore, a rectangle is a parallelogram with four right angles. That's what makes a rectangle a rectangle. Now imagine if you were to take a parallelogram and instead of four right angles, you were simply to make all four sides congruent in length, all four sides. You would get a rhombus, commonly known as a diamond. Sometimes it's drawn this way, vertically, all four sides equal, or sometimes sideways. But either way, all four sides equal, that's a rhombus. Therefore, a rhombus is a parallelogram with four congruent sides. So, quick recap. A rectangle is a parallelogram with four right angles in the corner. A rhombus is a parallelogram with four congruent sides. Therefore, both a rectangle and a rhombus, let's move the word rectangle here because we're going to be marking there, rectangle and a rhombus are parallelograms, which means they both have the OCD qualities. A rectangle has 4 right angles. Rhombus has 4 congruent sides. They both qualify as parallelograms. Now, what makes a rectangle unique is you have 4 right angle corners. That's what makes a rectangle unique. And because of the 4 right angles, draw on the 2 diagonals. I'd like you to finger pinch the length. So put one finger and thumb on either side here on the blue. Now, compare that to the length of the green. Go back, compare the length of the blue to the length of the green. What you notice, or should notice, is that the diagonal lengths are congruent. Now, because if the blue and the green are congruent in length and we have a midpoint here, that means all 4 of these pieces have congruent lengths, all 4 of them. Which means when you're working with a rectangle, I'm just giving you a heads up, you need to watch out for isosceles triangles because they're going to pop up. You also need to watch out for these longer outer right triangles. Now, what's unique about a rhombus is 3 things. 1, you have 4 congruent sides. That's what we start with. The next 2 deal with the diagonals. Draw on the diagonals. The first quality is that the diagonals are perpendicular. Perpendicular, the symbol for perpendicular is upside down T, which means you got a right angle, not at the corners, but you have a right angle in the middle. And the next thing you need to know is that the diagonals bisect the corner angles. They cut these corner angles in half. So a rectangle has 4 right angles and congruent diagonal lengths. A rhombus has 4 congruent sides, perpendicular diagonals, and those corner angles are being cut in half. Now, because of that right angle in the middle, in a rhombus, you need to watch out for right triangles. Here's your quad family tree. This is what we've covered so far. OCD qualities of a parallelogram. A rhombus, which is a parallelogram with 4 congruent sides. A rectangle, which is a parallelogram with 4 right angles. And you see here the arrows go back to the square. That's because here's a parallelogram. It has OCD qualities. The rectangle and a rhombus have those OCD qualities, and the rectangle has 2 additional qualities. And the rhombus had 3 additional unique qualities. If a rectangle and a rhombus get married, and they have a kid, they are having a square. So all the qualities of a rhombus is in a square, including the 4 right angles, diagonals bisect each other, and you have congruent diagonal lengths. And the diagonals in a square are perpendicular, and they bisect the corners just like a rhombus. So a square is the kid, if you will. It has all the genes of both a rectangle and a rhombus. We're going to do one problem together focused on a rectangle. What I'd like you to do is I'd like you to pause the video and give yourself 2 minutes and see how far you can get completely on your own. See how far you can get completely on your own. And then restart the video. Alrighty, welcome back. It says, we have a rectangle below, trace and mark the given information on the diagram, find all possible angles and sides. Now, the minute you say it's a rectangle, let's start marking what we know is true. We have 4 right angles. Opposite sides are congruent. All 4 of these pieces are congruent. Okay, let's mark what we know is true. So E to I, that's going to be 2x plus 1. F to H, which is the whole thing, is going to be 3x plus 10. And then we're given the measure of IFG, the angle IFG. We're told that that is 51 degrees. We want to find the measure of all angles and sides. We're going to go for the angles first. Because I have a right angle here, the first thing I can do quite easily is simply 90 minus the 51. Of course, I get 39. You're like, what else can I find? Well, remember, all 4 sides are equal, which makes this an isosceles triangle. So if that's 51, this right here is 51. Take it away from 90, and we get 39 here as well. Keep chasing it down. If I have 2 equal sides, I have 2 equal angles. So if that's 39, this is 39. Then if we go like this, armpits of the Z. Trace it so you can see it. Armpits of the Z. That means this right here is 51, and again, an isosceles triangle, you just walk it around. Okay, you think you're done, but wait, there's more. If you add 51 and 51, you get 102. Take it away from 180, and you get here 78. Vertical angle 78. Which means this angle right here, 102, and this angle, 102. There. Now we have found all the angles in the diagram. Now we're going to go for segment lengths and sides. We're looking at the red and the green. Let's do a thing equation first. The thing equation is this. We know that the one blue segment is equal to 2 of the red segments. It takes 2 reds to make 1 green. So using that as your equation, we're going to solve. Our blue is 3x plus 10, 1 red, now 2 reds equal a green. Now you can solve. You plug it in, check your work. If x is 8, 2 times x is 16 plus 1, that means that's 17, which means this is 17. And then we can check 3 times 8 is 24 plus 10, that makes this whole thing 34, which is 17 and 17 as well, so that you know you've checked. So 34 and then 17 and 17, and that's a true statement. Okay, you think you're done, but wait, there's more. Remember I said all segments, and if you look very carefully, wait a minute, we don't have this outer edges, and we don't have the longer edges yet. We don't have the outside of the rectangle. We ask yourself, how do we do that? Remember, not only do you watch out for isosceles, you also want to watch out for right triangles. So I'm going to pull out this one right triangle so it's easy to work with, and now you're going to see why we spent so much time on right triangles. So right here, this length is 34. I'm going to work this right triangle. I'm going to pull just the 39 down because I only need one angle. And now I'm going to solve for, I'm going to call this x, and I'm going to call this y. You ready? From the 39, that would make this opposite. That would make this adjacent. This our hypo. So to solve for x, I have an OH combo. To solve for y, I have an AH combo. So to solve for x, that's going to be sine of theta over 1 equals opposite over hypo. To solve for y, using the 39, cosine theta over 1 adjacent over hypo. You thought you could forget that because it's the previous chapter. Surprise! You should be able to do this without watching the video, but follow along if you need to. So x is going to be the sine of 39 times 34. I'm going to take it to the first decimal place, 21.4. So x is 21.4 here. And y is going to be cosine 39 times 34. I get 26.4, which makes sense because this is longer than that. And then you go back up here and we have officially found every single segment, 26.4, 26.4, 21.4, 21.4, every single segment, and every single angle in this rectangle.